So, welcome participants once again who are viewing it online for the second part of my sessions. So, in the previous part, I covered the inferential statistics and basic concepts surrounding the inferential statistics. Now, we will start with a discussion on parametric and non-parametric techniques. And we will understand what they are, how do they differ, what they basically do or test, and if there is some time left in today's, because we have two more sessions after this, so if there's some time left in today's session, we will go 2 hour. Otherwise, we have two more sessions. We will cover that empirical part then also, but we will cover it in the all the 4 sessions that we have planned. So I will be sharing the PPT for your convenience, and we will be providing you the PPT. So before coming to parametric tests or techniques, let me basically, first tell you that why there are two types of techniques. Because despite so many years I have been fortunate enough to carry out research and data analysis for about 8 years now. But in 8 years, I have still felt that both types of techniques are needed as per different situations. So let's understand what are parametric and non-parametric techniques. So first of all, we need to understand the word. What is a parameter? So anything which is related to the population, we call it as parameter. So for example, when we are talking about population average or population mean, then it is a parameter. If we are talking about population variance, then it is a parameter. Or if we are looking to see the, for example, the correlation between two variables in the population, then that correlation coefficient for the two variables at the level of population is also a parameter. So parameter is something which is related to population. And I don't know if some of you are aware about this or not. Something which is related to sample is called statistic. So some people also claim that that's how we got the word statistic. Anything which is related or which is calculated for a sample data is called statistic, and anything which is calculated for the whole population is called a parameter. So parametric techniques are those techniques which make assumption about the population parameter, and non-parametric techniques are those techniques which do not make any assumption about the population parameter. And that is why non-parametric techniques are also called as assumption-free techniques. They do not make any assumption about the population parameter. Now, why we are talking about making or not making an assumption about population parameter? Because in our previous session on inferential analysis and inferential statistic, in the beginning only I had explained to you that the fundamental idea is that we conclude something or we try to arrive at any decision or recommendation about the whole population from the sample. So when we are trying to arrive at something about the population from the sample, we will have to make, or we will have the choice of making any assumptions or not making any assumptions. So that's the context in which we are talking, that whether we want to make assumption or we don't want to make assumption. So there are techniques available for both kind of situations. So the basic idea remains same, which we did earlier, that we are trying to generalize from sample analysis, we are going to generalize the findings for the entire population. So the parametric techniques have many assumptions, but so sometimes these assumptions of parametric techniques are not met in the real life. And it is then that we really face a challenge. That, for example, if our one of the assumption, as you can see here, is that the data should be normally distributed. The If, for example, what will happen if the data is not normally distributed? In the last, towards the end of last session, I had also told you that there is something called central limit theorem. You can use central limit theorem to assume normality, but for that also you need to have large sample size. So what if you have very small sample size and the data is not coming out to be normal? So normal data is an assumption of many of the below mentioned tests and those tests which we are going to do. So in that case, you will be caught in a trap. Though there are some new developments also, there is a procedure called bootstrap, that is available, which draws, even if you have limited sample, it calculates further and further subsamples as different combinations. So that helps, but still the problem is there. So parametric tests are applied or are very effective when the assumptions that they make are true. If these assumptions are fine, then parametric tests are very good and they will provide much superior and robust results. But in many cases, due to small sample size, or for example, you can see in the third point of difference that the assumption regarding scale of measurement of data. So if our data is not ratio or interval scale, that is metric data, then also we will face a problem in applying parametric techniques. So if the data is not normal, or the sample size is not sufficient, or the scale of measurement is not there appropriately, then we cannot apply parametric techniques, because parametric techniques make these assumptions. Assumptions come first. There is a famous saying also that all statistical techniques are useful as long as their assumptions hold. So you have to make sure that these assumptions are right or appropriate and they are satisfactorily met before applying these parametric techniques. If they are not met, then we will have to go to non-parametric techniques. So for example, you see that the non-parametric techniques make no assumptions. For example, the non-parametric techniques make no assumption about the normality. They don't assume normality or any other distribution for the variables concerned. The non-parametric techniques are fine even with ordinal data or even with nominal data. You know that ordinal and nominal is the lowest scale of measurement. So if something is fine, if there is a technique which is fine even with nominal scale, then what is the problem? And also when we are comparing means across groups, so we need homogeneity. Homogeneity basically deals with they having the same structure or same distribution. So homogeneity of variance is basically about having the same dispersion or same variance or same data structure. So in another way, we can also put that the data should come from the same population. For example, if you are doing some testing between animals based on gender, you will not be comparing a male dog with a female cat, or a male cat with a female dog. You will be comparing male and female dog. You will be comparing male and female cats on some parameters, whatever is the research study. So this assumption of parametric technique is that they should be part of the same population or same broad structure. So that is called homogeneity of variance. So that is a requirement in parametric test, but again, it is not required in non-parametric techniques. Then also there is an assumption that the data sets should be independent of each other. That is, that should not be impacting each other, but that is also not required in non-parametric. And because we have metric data, so you can see that we are using ratio or interval data in parametric techniques. So we can go on to compute the mean. But in non-parametric techniques, we are not using metric data. We are using categorical data, ordinal, nominal data. So in here, we cannot always compute the mean. So in non-parametric data, it is often common that we compare the median. We do not compare the mean, we compare the median in a non-parametric analysis, because you know median can be computed even using the ordinal or nominal data, because median is about arrangements. So even if you have a data in which there is some order, so you can arrange the data in ascending or descending order and you can find the middle value, which will be the median. And benefits of parametric tests are very large. One is that they are very reliable, they are much more robust, and you know they can be used for further analysis also. But non-parametric tests are much simpler and they just do the job, but they are not comparable to the quality and effectiveness and further usability of parametric techniques. They cannot meet that standard. So having explained the background of difference between parametric and non-parametric tests, let me also tell you some examples of the utilities of these two techniques. For example, when we are looking to compare, I will give you a lot of examples for these situations, which will make it easier to understand. The simplest one to start with is correlation. So we all understand what is a correlation. Correlation is checking the relationship. And we know that correlation can be positive, correlation can be negative. So the parametric version of correlation test is Carl Pearson's correlation coefficient. And the non-parametric version, which many of you must be aware of, is Spearman's rank correlation. Now remember, rank, which scale of measurement corresponds to rank data? We call the measurement as ordinal. Ordinal is the one which is corresponding to ranked data. So Spearman's rank correlation can be applied on ordinal data, but Carl Pearson's correlation cannot be applied on ordinal data because that will not meet the requirements of a parametric technique, which Carl Pearson's method is. And similarly, we will look at these substitutes. For example, if you are comparing independent measures. Okay, let me also clarify what do we mean by independent measures and repeated measures. So if you are comparing something across two independent groups, for example, if you are comparing academic performance across two genders, so obviously a person will fall in either male or female gender. So they are two separate groups. So two separate classifications. So we call them independent measures. And there can be many more examples. For example, in economics, there is an big issue of which is very fundamental and critical to the health of banking sector and financial system, is the problem of NPAs, non-performing assets. So we often blame that public sector banks are lagging behind in NPAs, or due to inefficient management, corruption there. But nowadays we also have a lot of scams, private sector banks, and all those issues are there. So there are three types of banks in India from ownership perspective: private, public, and foreign. So if we have to compare the average level of NPAs across these three types of banks, so each bank will be divided in either as private or public or foreign bank. Any one bank cannot be in two categories. So they are independent of each other. All the three classifications are independent. So independent means you are having separate non-overlapping classifications. Repeated measures is when the underlying data is same and you are repeating it in two different situations. A very good example for it can be for example, patients. So vitals of patients are taken before we administer to them some medication or treatment, and vitals of the patient are taken after we administer to them some medication or treatment. So there is same set of 100 patients. We test them in before situation, that is before the administration of medication, and after the administration of medication. So this is an example of repeated measures, two conditions. Another example of repeated measures, more than two conditions, for example, during the initial days of COVID pandemic in 2020, there was lot of research going on. Still there is going on, but at that time there was a frenzy of research going across in the medical fraternity and amongst the doctors as to what could be the suitable treatment for this COVID pandemic and coronavirus that is there in our bodies. So a lot of things were happening. Some were giving the medications of malaria and other previously known treatments. Some were looking at plasma therapy, that is giving the blood from a person who has recovered from COVID. So they have COVID antibodies. So transfusing their blood into a patient and seeing how that works. Another could be not doing anything at all, just giving medications for some kind of symptoms as and when they appear. So if there is a symptom, you give some medication like for fever or something, and otherwise you just don't intervene, you let it pass. So we have three situations. So same underlying patients can go through three different situations, but this case, if there are three different sets of people, it will again go to independent measures like three different types of banks. But If the same patient, for example, if for the same patient, we start by giving them no treatment, and then we start with anti-malarial or some antiviral drugs, that will be the second situation for the same person. And then we can go to the stage of giving, say, trying out plasma therapy. So that will be the third situation with the same person. And after each, we will compare that how much is the improvement in the health of the patient. So this will become repeated measures for more than two conditions. Also, for example, for the same set of people, it is very difficult to do in practice, but let's assume for the same set of 100, 1,000, 10,000 people in the economy or in business consumers world, you for the same 10,000 people or for the same, for example, 10,000 investors, you ask them what is the state of economy and the prospects of economic development. It's very funny how the last, and also very sad how the last few months have been passing after the second wave in early November, October. We were very happy, all glad that finally vaccines are here, COVID is gone, and economy is all going to go up. And in November, and we got the news that there is a new variant which spreads much more fastly, which is called Omicron. So that caught up the whole world's attention, including in India, till at least January. And again, then we found that, okay, it is very mild and it will again pass. Vaccines are working against it, very minimal damage. So again, we were going happy. But then, in fact, government was also planning a lot of IPOs like LIC IPO. But again, we now have this geopolitical crisis of Russia and Ukraine, which is very sad because of the war and devastation. But that's how life is. We again have a change. And again, now everything is back to the wall and markets are crashing. So if you ask the economists, so what is their prospects, and you see that all the major institutions are constantly revising their growth prospects. If you ask them in November, if you take their figure in January, and if you take their figure in March, every time they are updating their things. So for the same set of policymakers, same set of economists, if you ask them what is their GDP growth forecast for the next year or even for the last quarter of this year, so that will differ at different points of time based on the prevailing circumstances and their expectations about the future. So that will again be in repeated measures. Why repeated measures? Or because the underlying data, underlying sample is same. So that's the thing. And so now let me come to the parametric techniques. So in the parametric techniques, a very common thing that we do is that we compare the means. Now it may appear very simple, what is comparing means to do, but it is actually very, very powerful. In fact, I am an academic researcher, sir is an academic researcher, and many of you may be participants who will see the video later on are academic researchers. So I can tell you that in some of the best journals, you will find research papers, top journals of the world, research papers published just on the basis of not even correlation regression, because that is also not required. Just on the basis of parametric techniques or comparing means, you will find some research papers published in one of few of the best journals of the world. So parametric, because you see, these may appear to be as very basic, but these are fundamental techniques. And the applicability of technique is always subservient to your research or analysis problem. So please always remember, participant, don't just go after fancy techniques, even if they are not suitable to your research problem. You know, your papers will get rejected very easily in the early stage. Nobody is now going to buy just the analysis based work. You have to see that what is the objective, what are the variables, which method is suitable to meeting your objective, and analysis should be done according to that. So first question is that the broad thing that I'm telling you is that for comparing means we use t-tests. So immediately you would ask that why we use t-tests, why we do not use z-test, for example. So this is a very common thing. I think all of you are aware of this, that when to use t-tests. So we say that when population standard deviation is not known and both the conditions should be met, and the sample size is less than 30. So we should use the t-test. But just look at these two things, and then you will understand that why we use t-tests almost universally. So can you think of any circumstance in which the population standard deviation will be known? Just imagine that to know population standard deviation, you need to have the whole data of the population. Then you will compute the population mean, and then because standard deviation is average deviation from the mean, so you will first compute population mean, and then you will compute standard deviation. If you already have those things, then you can make any inference about the population just by applying descriptive analysis. Always remember the point that I told you in the previous session. Why we are doing inferential analysis and all these hypothesis tests? Because we do not have the population data. If you have the whole population data, even descriptive analysis is fine. You can arrive at any conclusion because you have the data of whole population. We have to apply these inferential and hypothesis techniques because we do not have the whole population data. We only have the sample data. So rarely or almost impossible to assume any situation in which the whole population data is there and you can calculate the mean and standard deviation. So the first condition is almost always met of using the t-test. And for the second condition, it says that sample size should be less than 30. But even if the sample size, because I told you in the previous session that there is a central limit theorem, and the usual thing that they take is the sample size of 30. So for more than 30, you can assume normal distribution for your sample data. So why do we say this? Why do we not use Z distribution if the sample size is more than 30? It is because for sample sizes more than 30, the T and Z distribution, or the T and normal distribution, are almost mirror images of each other. They resemble, the T distribution resembles the normal distribution as the sample size grows larger and larger, especially when it crosses the benchmark of 30. So below 30, T should be used, and above 30, there is not much difference between T distribution and normal distribution. So ultimately, in both the cases, universally, we use T distribution. And then what are the tests? What are the parametric tests that are available? So the parametric tests that are available are one sample t-test, independent samples t-test, paired samples t-test, and we also have their non-parametric versions. The non-parametric versions I have provided here in the PPT. So we have the Mann-Whitney test, we have the Kruskal-Wallis test, we have the Wilcoxon test. These are the non-parametric substitutes of these one sample, paired sample, and independent samples t-tests. And if you are comparing more than two groups, now t-test can be used to compare only two groups. So for example, t-test can be used only when we are comparing, say, the academic performance of students from two genders. And if we are taking genders only as male and female, we can do the comparison. But for example, if you are taking three streams which are common, science, arts, and commerce, arts or humanities and commerce. So if you're taking three streams of students and you want to compare their academic performance, so that is more than two groups. So for more than two groups, we cannot apply independent samples t-test. So for more than two groups, we use what is called one-way ANOVA. One-way ANOVA, or ANOVA is a shortcut for the term analysis of variance. So if there are more than two groups, we use one-way ANOVA, and one-way ANOVA can also be used for two groups also, and it can also be used for more than two groups. But if there are more than two groups, we cannot use independent samples t-test. Independent samples t-test can be used only if we have two groups. So this is the background of these tests and why they are used and how they are used. So let me now take you to probably to the R software, and we can see if we can do something. Okay, and one more thing which is there, which I would like to explain, is the chi-square test. That is also a very common and very popular test. So I would also like to explain. Just give me a second. I will open a very good example of chi-square and crosstabs. So I would like, because there is not much time left today, so I would like to cover the basics, and then we will share with through the organizers. I will pass on to you the data sets. So in the remaining sessions, you also have the data sets, and then you can carry out the analysis, and then you can come up with doubts in the, since it will be live session, you can ask at the end as also, or you can come up with the doubts after practicing on next day also. You can come up with the doubts and share with me. Yes, so we have one more technique apart from these, comparing means in the related samples and in the unrelated or independent samples. Apart from that, we also have what we call as cross tabs. And so the example that we are discussing here is that of cross tabs, or which is shortcut for cross tabulation, and chi-square test of independence. So let's also understand the concept of it. And since you will be having the videos with you, so you can also refer back to it again and again. That's the advantage of having online classes also. You can refer it back once again before we do the practicals in the next session. So let's take two examples, one from a corporate world and one from the general politics. So suppose you know that in India we have major groups of political parties. You also know that in USA we have two major groups, which are the Republicans and the Democrats. So suppose we want to ask this question to our participants, that, or the voters, that we want to find out that the voters of which political party are more prone to switching or flipping in the most important elections, which is the presidential elections. So is it that, for example, the Democrat voters are more prone to flipping or switching side? Flipping or switching side means in a presidential election, they may vote for the non-Democrat candidate. And similarly, a Republican, if they switch, they may vote for a non-Republican or a Democrat candidate. That will be considered switching. So we need to find out that what is this? Is there any difference, or it is same? So there will always be a small fraction of voters in both who will switch. But what we want to do is that we want to compare that, is it that proportion of voters who switch, is it same for both the political parties, or is it more in Republican, or is it more in Democrats, or whatever conclusion we will arrive, it will be based on data. But we can assume, we can make an hypothesis that the proportion of voters who switch is same across the two political parties, and in the alternate we will put that the proportion of voters who switch is different for the two political parties. So you look at this table. So what we have done is that we have asked a very simple question to them. We have asked two simple questions, the responses of which are categorical. So we have asked them a question that, what is your political orientation? And we gave them these two choices, that whether you are a Republican or a Democrat. And we asked them this, that have you ever switched or flipped sides in a presidential election, US presidential election? Yes, no. So we just asked them two questions. And then we can create this kind of matrix. And this matrix or table is called cross table. Cross table, or popularly cross tab. So this table is a cross tab. What we are essentially representing, we are essentially representing one variable in rows and another variable in columns. And then we have the cells which are representing these numbers or values. So for example, what does A represent? A represents those Republican voters who have switched sides. B represents those Democrat voters who have switched sides. C represents those Republicans who have not switched sides, and Democrats represent, D represents those Democrats who have not switched sides. So these ABCD items cannot be, just read from the column or the row. They have to be read as an intersection of the column and the row variable. So this is a cross tab. You are basically representing two variables in one table. Now, if we have to find that are the voters of one particular political group, are they switching more than other, or is it same? So we can see the absolute count. So for example, we can compare A with B, because A is the number of Republicans who have switched and B is the number of Democrats who have switched. So we can compare A with B. But that will not be a very robust thing to do, because, for example, the total number of Republicans or total number of Democrats in our sample may not be equal. We may have more Republicans or we may have more Democrats. Obviously, if we have more Republicans, there is a more chance that we will have a higher A compared to B. Similarly, if we have more Democrats in our sample, we will have higher B compared to A. So the better thing would be to take a proportion or a percentage. So what we can do is that we can find that what percentage of these are absolute numbers. A, B, C, D are absolute numbers. 100, 150, 200, 250. These are absolute numbers. So we can find the proportion of this out of the total. So we can do A divided by A plus C. A divided by A plus C will result in the proportion of Republicans who are switching, because A are those Republicans who have switched, and divided by A plus C, because A plus C are the total number of Republicans. So A divided by A plus C will mean the fraction or proportion of Republicans or percentage of Republicans that they have switched sides. And similarly, B upon B plus D will give us fraction or proportion of Democrats who have switched sides. So we can compare the proportion of the Republicans and Democrats who have switched sides. And that comparison is facilitated by what we call as chi-square test of independence. So why it is called a test of independence? Because we are testing whether the two categorical variables are related or they are independent of each other. So are these two variables related to each other? If they are related, then whether someone is switching or not switching in presidential election will depend on the party to which it belongs. And there may be a more chance of someone from one of these parties switching. But if they are not related to each other, switching and the political orientation, then then there will be no difference. These two variables will not be related. So it will not matter. The switching behavior will not depend on the political orientation. If they are related, the switching behavior in elections will depend on the political orientation. So this is, we are trying to establish the relationship. Another very interesting thing that is often studied and researched is the problem of glass ceiling. So women in society, we have a long history of their under participation in leadership, economic and external roles beyond the domestic family. And there has been a lot of changes and progressions that have happened in the last few decades, but it is still widely seen that women are not so well represented at the top levels in businesses as well as in political leadership. If you see how many prime ministers or presidents and heads of states have been women, you will get the answer even in modern world, because the population is around 50%. But still, what is the proportion of women in leadership roles as heads of states, prime ministers, presidents, or even chief ministers of states or provinces? And similarly, how many what is the percentage of women as heads of companies and private corporations? So we often see or feel, and in the real life, that there is a differentiation. So there's what we can call as glass ceiling. Glass ceiling, because there is an invisible barrier. Glass, it is made the barrier is made of glass, so you cannot really see it, but there is a barrier which is rare, which is limiting the transcendence or upward movement of women in corporate or political roles. So if you want to study it in corporates, then you can carry out a very simple study. I'm also giving you a lot of ideas for research. So for example, you can collect data of corporate sector employees who are in managerial positions. Because see, in corporate world, you have blue collar workers and white collar workers. White collar workers are all managerial people who direct, who have reportings, who are in leadership or team roles, team handling roles. So managerial level people are one step above, and the blue collar workers, even if they are skilled, then also they are blue collar workers. So they are executing the task and following orders and reporting to their managers. So amongst those corporate employees who are managers, you can take a survey, a very simple survey. You need to ask just two questions. One, at what level are they working in their organization? So those who have joined immediately are basically working as management trainees or executives, and some would be after 5 to 10 years they will be in mid levels, and post that they will go to the top managerial positions like CEOs, CFOs, chief financial officer, chief HR officer, HR head, marketing head, presidents, vice presidents. That would be senior or top managerial positions. So we can ask people that what is the level of management in which you are working, and we can ask the person their gender, and it will be very very easy and yet a very powerful and very interesting thing, that does the proportion of men and women at whatever is their proportion of proportion at the lower and middle level. So you may say at this point that in general the participation of women is also less in workforce. So I'm giving you a solution for that also. So suppose even in the lower level of management, suppose the participation is 60-40 or even 70-30, and that continues in the middle level also. So 70% are men and 30% are women. But at least that 70-30 ratio should also go to the top level. If there is no description, if there is no discrimination, then as women have risen from lower and to mid level, they should also continue to rise and go to the top management level. But if in the top management level you see that despite a 30% or 40% representation or 50% representation at mid and lower levels, if you see that in the top management level there's a representation of say less than 1% or less than 5%, then you will notice that there is a problem of glass ceiling. It is other matter. You will have to do a separate research to find out the reasons for it. Many say that it is also reluctance from women's side to apply and take up those, because those roles are very challenging and time consuming. So often women are not free to apply and take due to family and societal obligations. And sometimes there is also a blame that men do not allow women to enter those roles. So whatever it is, that reasons will have to be figured out later on. But the first thing is that if the proportion of women at mid and lower levels does not continue to the top level, then we will clearly see that there is a difference or there is a biasness that is going on. And that will provide us sufficient evidence for glass ceiling in corporate sector. So there can be many more problems that you can visualize like this. You can take any two categorical variables. And by the way, this crosstabs and chi-square test of independence are the primary techniques and the most common and most important techniques if you want to do any kind of analysis between two categorical variables. See, there are a lot of techniques available for doing analysis between numeric variables. You have correlation, you have regression, you have several types of regression. There are many numeric techniques if both the variables of your analysis are numeric. But if both variables are categorical in nature, there are not many techniques. And the most prominent ones are this crosstab and this chi-square. So crosstab will do what we call the descriptive analysis in form of frequencies, and the chi-square will do the hypothesis testing part when you want to generalize the findings for the entire population. So that's what I wanted to discuss with you in today's session, that we have covered all these parametric and non-parametric techniques which I showed you. And I have also given to you the background of these techniques, that what they essentially mean and how they can be used. So in the next session that we will have, by then you will also have the data sets with you. We will share it. And on those data sets, we will carry out the analysis and interpretation with some more examples in the R software. Thank you so much, Saurabh sir. Saurabh sir is a great colleague and so helpful in conducting the sessions. Thank you, sir.